Hey there, Nick Jonatakis here. In this talk, we're going to go over all sorts of different tips and best practices around Dockerizing a web application and using Docker Compose. These are all tips and patterns that I've picked up over the years while working with Docker as a freelance developer. Just a heads up, by the way, this whole entire talk is going to be a live demo, not a single slide in sight. But before we get into that, let me just very quickly introduce myself. So my name is Nick Jonatakis, and I've been a Docker captain since 2016. I've been working with Docker since 2014. I have a blog here with a couple hundred blog posts and videos about Docker and other web development topics. I also have a course called Dive into Docker, so if you're brand new to Docker and you're coming at this from ground zero, you may want to check that out. Lastly, I have a podcast called Running in Production, where I talk to different folks about how they build and deploy their web applications. I wanted to quickly bring this one up here because if you sort this by Docker, you can see all sorts of different examples of people using Docker out in the wild. Either this could be deploying to a single server using Docker Compose or a couple hundred nodes on a Kubernetes cluster. So now let's get to the good stuff and go over the example Flask application. And by the way, if you're not a Flask developer, then don't feel like you need to bail out now because everything we're about to go over will apply to any other web framework, and we're not really going to go over any Flask specific code. I also do have other example applications that are ready to go for Django, Rails, Node, Phoenix, and Play. And when it comes to Play, I just want to give a huge shout out to my friend Lexi here, who put in a lot of effort and brought her JVM and Scala and Play experience to the table. So thanks to her, we have the example Play app. Also, just a heads up, you don't need to pause a video or stream or wherever you're watching this to get any links mentioned in this talk. This one tooltip I put up right now has links to everything for all the references there, so feel free to check that out whenever you want, perhaps after the talk. Now, let's go over the tech stack before we jump into the code base, because I feel like this tech stack is pretty similar for a lot of different web applications written in a lot of different web frameworks. But, the TLDR high-level overview is, we have the web server itself, we have a background worker, a database cache, as well as Webpack. That's what all these technologies here are. I didn't list the web server here because, we're dealing with a web application, so it's kind of implied. But, the takeaway here is like if you wanted to swap out Postgres for MySQL or something else, that's really not a big deal at all. Celery in this case is the background worker. If you're more familiar with Rails, you might have heard of Sidekick. That's a similar tool. And Redis is Redis, and we have Webpack and Tailwind. If you want to use Bootstrap instead, that's an application level change, not a big deal. But the basic idea about this project is, it's MIT licensed. You're meant to clone it down. You can build your application upon this. It's basically like a starter project for all those different web frameworks I mentioned as well. So that's basically what we're working at here. So I'm going to pop open a second terminal window here just so we can take a look at the project in a browser before we take a look at the code base. And by the way, all the installation instructions are here in the README file, so you can check them out when you'd like. And I'm going to head over to localhost port 8000, and this is the application. So there's a couple of versions as well as the environment. These are all being pulled in at runtime through environment variables, and the other example applications for like Rails, Django, etc., they all look similar to this, but have different logos and slightly different data here when it comes to things like the Flask env. But this is the application that we're working with, all styled up using Tailwind. So now let me jump over to a code editor here, and we'll begin by taking a look at the docker-compose YAML file. So right away at the very top of the file, notice that there is no version 2 or version 3 defined. That's because this file is using the new Compose spec, which is available with Docker Compose 1.27. I believe that was released sometime in September in 2020, so it's been around for a while now. But also, by the way, for the sake of time, can't really go into like Docker 101 stuff, like what is a volume, what is an env file. But we are going to go over some very basics here when it comes to the services, because it's going to lead into the first pattern. So take a look here, right? We have the Postgres service, we have Redis, we have web, and we have worker. That's part of the tech stack that we went over before in the README file. And if I jump over to the other terminal here, notice when I ran the Docker Compose up that, Postgres, Redis, web and worker are there, but there's also Webpack in the middle here. And if I scroll down to the bottom, notice, Webpack clearly is running. If I go to the browser, it's serving all of the CSS that we see here. But, going back to this compose file, there's the worker, there's web, there's Redis, and there's Postgres, but where is Webpack? It's not hiding at the bottom of the file. It is nowhere to be found, at least not in this file. And that leads us to our first pattern, which is the Docker Compose override pattern, where this one is awesome because if you run a Docker Compose up like this with no arguments, then, this is stuff that you probably know, right? It's Docker Compose is going to look specifically for a docker-compose.yml file, but it's also going to look for a Docker Compose override file that needs to be named exactly like this with the dots, etc., etc. And if this file happens to exist, then Docker Compose is going to combine both this Docker Compose YAML file as well as this override file into one file, and then it's going to run that as basically one unit. So that's what we see here. We do a compose up, and there's all the containers. So now let's go over this override file here, and it looks very, very similar to a standard Docker Compose YAML file because that's exactly what it is. In this case, we have a list of services, and there is Webpack. There's also this example file as well, which we'll go over in a bit, but for now you might be wondering, like, Nick, why go through all the trouble? Why to this override pattern and put Webpack here when you can just go to this compose file here and put it at the bottom or wherever, and that is a really good question. And, this override pattern comes in very handy when you want to run certain containers in development, but not in production. And in this case, when it comes to Webpack, we saw that the Webpack watcher is running here in development, which is awesome because it means if you change your JavaScript or CSS, then you'll be able to just go to your browser, reload and see it while Webpack updates in 100 milliseconds or whatever, however long it takes. But in production, typically you wouldn't be running this Webpack development server. Instead, you'd just be running your web app and your database and everything else. But, Webpack will produce bundled CSS and JavaScript files that you can then directly serve from Nginx or, whatever tool that you want to serve your assets from, maybe a CDN, etc. And what this override pattern allows you to do is define something like what we see here, where Webpack is in the override file, but then in production, this override file wouldn't make its way onto the system. Let's just say that you're deploying to a VPS and you're running Docker Compose up there. So, and this also falls into why we have the example file as well, because, in development, it's going to combine this compose file and the override file. Everything is going to run and it's going to be amazing. But I actually do have this override file, the YAML one, get ignored in here. So if I go to the get ignore file, then we can see this override file is ignored. And by the way, I have the same pattern here for the envs. So .env has sensitive information in it. Totally don't want to have that stuff commit to version control where you might have something like Stripe keys or API credentials. But we do have the example env file as well. I know I'm jumping around, but this really relates to this. But this example file is commit to version control. It doesn't have any secrets in there. It's meant to be used as basically documentation. And we have the same exact pattern here for the override file. So this file that we see here, the override file, it is exactly the same as the one that we just looked at, but this one's actually commit to version control because when you clone down the repo, then you can just do copy Docker Compose override example to the regular override, and then in development, you're all good to go. But since it's ignored from version control, the actual file itself, when you push your code up to your server, then the override file won't be there, and suddenly Webpack is not running in production. Instead, you can just serve the assets directly, and you don't get this extra container. So this is a really, really nice pattern because typically, if you weren't aware of this pattern, you might go down the route of having something like a Docker Compose dev file and like a Docker Compose prod file. And before you know it, you have all this duplication between all these files. And really, you're just wanting to control whether or not one container is running in dev versus prod. So that's really the first pattern of this file, the override file. And there's another pattern here to reduce some duplication as well, because, if we scroll down here, we have the web service as well as the worker service. And both of these services are very, very similar. So, if you've never worked with a background worker before, typically what ends up happening is the background worker and the web server use the same exact Docker file. And the only difference is the worker will just run a different command. So, this is Docker 101 stuff. But if I jump to the bottom of this Docker file, which we're going to get into, by the way, a little bit later, this runs gunicorn, which is the web server in Python. And, we just have this set as a CMD, all good to go. That's pretty standard stuff here. And if we look at the web service here, notice that there's no command being defined because it's just going to use the CMD by default. But when it comes to the worker, it's running that celery background worker instead. But the interesting takeaway here is, take a look at the syntax here where we're defining some crazy looking pointer thing with a reference to somewhere. And this is called aliases and anchors, and it's a YAML feature. And it combines with another feature from Docker Compose called extension field. So if I jump to the very top of this file, we have this extension field defined for the app. And by the way, this app and this app doesn't need to line up. But notice how we just have a whole bunch of different properties for Docker Compose defined here, like the build, the context, what arguments get passed in, depends on env, all these properties here. But if we jump back down to the bottom of the file, notice that the web service and the worker service, they're both referencing that extension field. You can think of it kind of like a variable, right? And all of those properties at the very top of the file that we were looking at up here, they're basically going to be, essentially copy pasted down here, except we're not actually copy pasting it, right? We can reference them like a variable. And what's really neat about this one is, we might have something like 6 or 7 common properties between multiple services, in this case, the web and the worker, and we can share all of them. But then when it comes to something like the web, we might have some extra things that we want to set, or, even for now, specifically for the worker, it's like we want to set that custom command. So we can just define other properties that we want to set here for specifically on the worker and specifically for the web. Like for the web, there's a health check here because, it's actually like an HTTP web server, but the worker is not. And then likewise, we want to publish some ports here for the web, but not for the worker. So, we have really nice control here to basically put all of our duplicated stuff into one property up here. And by the way, it needs to start with x dash. That's just part of the compose spec. If you didn't do that, then you're going to get an error because compose won't recognize the field. But yeah, that's basically how that works. And also, if you did happen to have that defined, a couple properties in this, but you wanted to override one specifically for like the worker, that's not an example here, but let's just say for argument's sake, I wanted to, I don't know, set the stop grace period to be 10 seconds on the worker. You can just redefine it down here and it'll take precedence over here when it's defined. So yeah, that's a really nice way to just reduce duplication. So now let's talk a little bit about environment variables because they are being used all over the place. So this is called variable interpolation. It's a feature of Docker Compose, and it's very similar to how variable interpolation works on the shell. So for example, when it comes to something like the health check here, Docker Compose will let you define a variable with $ squigglies and then this environment variable here. And if it happens to be not defined, then it is going to fall back to using this value by default. Now, keep in mind, we are referencing things like env file with a .env file here, but this is separate to this variable interpolation that's happening in Docker Compose. And using environment variable interpolation like this is really nice because it really dries out our compose file and makes it available for us to tweak certain properties here or there for dev versus prod. And that's what we see being used all over this file. So in this case, when you run a Docker Compose up and other compose commands, when you're doing variable interpolation like this, it's going to look for a .env file specifically. And, this comes in really, really handy because, let's go back down here to this health check. And by the way, I'm jumping around a little bit, but, health checks are really important. So, in the context of environment variables, let's go over this health check first because you may have seen this health check being defined in a Docker file before because, that is a valid thing to do. But personally, in my opinion, I really like having the health check being defined in the Docker Compose YAML file because it allows us, one, to change our health check at runtime just through an environment variable, but two, it also makes our code a little bit more agnostic to which container platform or tools that you're using to run it. For example, you might be running this project on a single VPS with Docker Compose, but, what if you run your application in a Kubernetes cluster? Well, Kubernetes is going to automatically ignore the health check instruction in your Docker file. So, why go even through the motions of having to expect another tool to do something like that when we can just define it here in the compose file? So basically the health check is only being used when we're using compose or swarm, et cetera, et cetera. And having it be changeable at runtime is also a really nice thing because if you're working with an application in development, so, here's the output of the logs, right? If I go back to this page here, and, I reload a couple times here, just hitting F5, and I jump over to these logs, we can see all this log output, right? It doesn't matter what the logs say, but, this is the web server just saying, hey, by the way, you access this at blah, 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 blah. Here's the HTTP 200 for the homepage. But if you have a health check running here, and let's say, every minute, and it's running and hitting this up endpoint, which we'll go over in a second, by the way, then every single time, every single minute in your logs, you're just going to get like health check, health check, health check, health check. And you're just like, shut up, man. Like, I just want to look at my logs in peace because I'm trying to debug some code, right? So do it up in production. But in development, let's just override that health check to be something else. So if we take a look here at the env file and I do a search here for health check, we can see in development, we are overriding that to run the bin true command. So if you're brand new to the command line, if you run bin true, then it's basically doing the most minimal work possible to do absolutely nothing, but it still returns back an exit code 0, meaning that it is going to pass any health check, right? It's basically saying like, yes, this works. So in development, we don't get spammed by our health check logs, but in production, we get to curl things up as we do. Now, going back to this compose file here for the health check specifically, this is not specific to Flask, right? It's a really good idea, in my opinion at least, to put a health check endpoint in all of your applications. So actually, let's switch gears real quick and just take a look at that really quick. I promise you it's not going to be very crazy code to look at here. But this is the Flask health check endpoint. It's in /up. It doesn't matter where you put it. That's just a convention I like to use. And all it does is it returns an empty 200 body response here, but it also runs a raw SQL command here to make sure we can do a select one in our database, as well as ping Redis to make sure that it's up, right? In my opinion, it's a really great idea for your health check to do, not just returning like a status code 200, but also checking to make sure if you can connect to the resources that you need, like a database, Redis, whatever you need. And, it adds a couple microseconds to this check, but it is totally well worth it because, these services need to be up for your application to work. And, doing something like a select one is a very, 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 very basic SQL command to run. For example, if I go and run psql here, by the way, this run script is a part of this example application. Can't get into this for the sake of the video, but it gives you some convenience function, so you don't need to run really long docker compose exec commands. But, if I run select one here, from a psql prompt, it's just basically returning back, yeah, the SQL command worked, which is really nice because this says that suddenly our database is configured properly and we can connect to it. Likewise with Redis, you can run a ping command and it just responds with pong. So yeah, very minimal health check. And that is how I have the health check set up. if you're using Rails or Django or something else, you can take a look at those apps. They have health checks defined there as well. Now, let's continue onwards, though, and talk a little bit more about environment variables because they are being used all over the place. For example, when it comes to setting things like, let's see the ports here, right? I have Docker web port forward, and then I'm just basically forwarding ports 8,000 to 8,000 in the container. So, this application itself, internally is running on port 8,000, but then I'm also publishing back port 8,000 as well. But, maybe you've seen something like this in a compose file where you might just see, 8,000:8,000, whether or not it's in quotes, not important. And, this is totally fine, but this doesn't really work that nicely in production. I mean, technically it could work, but there's some implications about this because when you don't define this with the 127.0.0.1 localhost essentially, then this, assuming you don't have like a cloud firewall in front of your infrastructure in production, this is going to expose, or not expose, it's going to publish this port to the host. So technically, like the entire internet will be able to access your application at, example.com:8000, which wouldn't be very good at all. So what I like to do is I like to make this an environment variable that, by default will bind this to only localhost port 8000, but the internet won't be able to connect to this service at all. So that is really nice. But you might be wondering like, well, why go through all that trouble? Like, where's Nginx, by the way? And when it comes to using Nginx, I really like to run Nginx directly on my Docker host. So this is kind of where this pattern comes together. So the idea basically is I'll compose up, -d or whatever in production, and Nginx will be running on the same exact server, and Nginx is going to be, available to connect to this web server over localhost port 8000. So Nginx can connect, it can start doing what it needs to do, like, setting up, SSL certificates and serving things as a proxy, serving all the assets, et cetera. And by the way, I can't get into it for the sake of time here, but I do have a blog post about Nginx and why I like to run it on a Docker host. I'll leave a link to that one in the references, but long story short, environment variables, yes, we are saying let's do that for localhost port 8000. But, sometimes if I go back to the env file here and we look up somewhere, I think it's down here. Yeah, here it is for the web port forward. In development, I just go for the 8,000:8000 and, it's accessible anywhere because, you might be running Docker Toolbox or some legacy system, or maybe you're running Docker in a VM where you just can't connect over localhost, or, in development, you might want to check what the website looks like on a whole bunch of different devices, right? You might have like a laptop or, an iPad or whatever it is. And in that case, you don't want to have it locked down to just localhost. You want anyone to be able to connect on your local network. So that's why I have that set up to be an environment variable. So going back to this compose file here, let's take a look at some other environment variables here. And we can see there's some for, web CPUs and memories. These are slightly different for worker and web. If you're wondering like, hey, why did you duplicate deploy? Like, they are slightly different. It's a really good idea, in my opinion, to put some memory and CPU constraints on your containers. They default to 0 right now, but if you know for sure that your container is going to use like 200 megs of memory or something like that, you can put that there. It just becomes a little more friendly if you're going to bring things into Kubernetes or another orchestration service. But let's punt on that idea for now and just continue going over other environment variables that are pretty useful. Like, for example, like the restart policy. So by default in production, it is going to be set to unless stopped, which, again, I really like the idea of defaulting to things in production so that in development, it's very, very, very easy to just like clone down the repo, copy the env file, and everything is set in the env file in development. But in production, you don't really need to set too many environment variables. But unless stopped is really nice in production because, if you reboot your box, then Docker will restart your container automatically or start it up automatically, which is really nice. But also, if your container crashes and it's set up in such a way that it can actually recover and it's not like an infinite crash, then, unless stopped, will keep trying, and your containers will be able to basically self-heal. But, in development, that's pretty kind of not nice, right? Like, imagine you reboot your dev box and suddenly like every container you ever ran in, every project starts like booting up. So in that case, what I like to do in the env file there is I just set the restart policy to be no, so that in development, these containers don't come up on their own, which is exactly what we want. Suddenly we have dev prod parity for something else. So going through this file, let's see, what else do we have here? We have the volume as well. Yeah, so let's wrap things up environment variable wise for the Docker web volume. So in production, as mentioned before with Nginx, right? Nginx is running on the same host as Docker, but the actual Nginx itself is running directly on the Docker host. And if you don't know too much about Nginx, right, it's a web server, it does a lot of great stuff, can't really get into it for the sake of time, but it has this idea of like being able to serve static files. And in the case of this Flask application, I have this public directory here. You know, it might be a little bit different with Rails. Well, technically Rails is a public directory, but other frameworks might have this in a different spot. But, you know, this is like where your HTML and your final CSS and JavaScript is. And we just tell like Nginx, hey, you know, it needs to be able to read these files and or directory. So in this case, for the volume, I just expose that public directory in production, and then Nginx can read that happily. It's all good. But in development, you know, if you're hacking away on your application, you want to be able to just change your app and then have the ability to reload your browser and see the change. So in development, then if I go back to the env file here, down here, we can see that it is just going to basically bind mount everything, right? The current directory into /app, and then suddenly we get all the nice goodness in development where we can just hack around in our code base and see the updates automatically. So within like a second or so. And so that's basically environment variables in the docker-compose YAML file. But, you know, let's go over some other environment variables like at the application level. So this will involve looking at some Flask code, but all of this really applies to any web framework. So right now I'm looking at this one gunicorn py file in the config folder. This is the web server configuration. You know, if you're using something like Ruby, you might be using Puma. So this could be like a puma.rb file. You know what to do with your web framework of choice. But in this case, there's a couple environment variables being set here. We can see that, you know, the port is 8000, it's binding on 0000, but the port is technically something that you can override, right? Because one other thing that I like to do with all my projects is, you know, I try to make them runnable on any container platform or any other platform in general. Like, for example, Heroku will specifically look for a port environment variable. So, you know, why not name this port so it's compatible with Heroku in case you want to run this app there instead of just through Docker Compose on a VPS that you manage yourself. And then also, likewise, with like web concurrency, these are naming conventions from Heroku. But, you know, a lot of web servers have the concept of workers and threads where, you know, you can technically spin up multiple processes or workers depending on which web application that you use. But in this case, like typically you would want them to be set to the number of CPUs that you have in the box times 2. Again, it's going to vary depending on what web framework you use, but that's a reasonable baseline. And then, yeah, same thing with max threads. In this case, it defaults to 1 because Gunicorn works like this. But yeah, having these available means that suddenly if you upgrade to a box that has like, you know, 8 CPU cores instead of 2, you don't need to like mingle around with these config files. You can just set a single environment variable. And, you know, if I go back to the env file here, and take a look at what it's set to in dev, I do override that to be set to 1 for the web concurrency number of processes running, because in development, typically it's a good idea to set this to 1 because, you know, if you're running like a debugger or something like that, it becomes very hard to debug your code when you have like processes forking under the hood. So yeah, another case of just dev prod parity where it's really nice. But going back to this Gunicorn config file, one last thing here unrelated to environment variables is logging to standard out. So with Gunicorn, you can just log to dash here, which is a Unix convention to log to standard out. But, you know, the alternative here is, let's say you were to log to something like an access.log file on disk, you know, inside a container that doesn't work very well because when the container stops, then you're going to lose those logs. So by logging to standard out, you can configure Docker to, you know, maybe access those logs through journald or whatever mechanism that you like. Maybe you're using CloudWatch on AWS or another centralized logging service. So this just makes it really nice to manage your log files outside of Docker just by having your web server configured to log to standard out. Now, since we're talking about configs and environment variables, let me just go over one other Flask configuration file. But this really is going to relate to any other web framework because it's related to configuring your database. So in this case, I just have Flask configured to set up a database connection, which expects us to pass in basically either a database URL or it's going to basically create a Postgres URI like this based on environment variables being passed in. So all these environment variables are being passed in from the env file because we have, you know, the env file property defined on our compose file. But, you know, for Postgres user and password, if you've ever used the official Postgres image, it's really important that those two are defined. But for things like, you know, the host port and DB, we can just fall back to defaults for that one. But the basic idea here is if a database URL is set, which you might be using on Heroku or something like that, then let's just use that. Otherwise, let's fall back to this, you know, database variable here, which is basically that custom Postgres URI made up of environment variables that are defined in the env file. You know, this is a really nice pattern because now it just means suddenly, like, let's say you're working on a production box where you might be using a managed version of Postgres or another database, right? On AWS, you might be using RDS. On DigitalOcean, you might be using their managed Postgres where you want to pop in a database URL and not be worried about using like a local version of Postgres, right? You can combo this using the override file because now you can put Postgres maybe in your override file instead of the normal compose file. And then, yeah, you can run Postgres locally on your dev box, but then in prod, you can just pop in the database URL with whatever managed database service that you use. But now let's switch gears and talk a little bit about the Dockerfile. So this Dockerfile is taking advantage of multi-stage builds, and there's two of them. There's one for Webpack, which is running in a node image here, the official node image. And then down here, there's another stage for the Flask application running in the official Python image. And I like to separate my stages here using a single comment. It just makes it a little bit easier at a glance to see when I'm jumping to a different stage, but I wouldn't say that's necessarily a best practice. And in terms of best practices in general, these are more like opinions, right? Patterns I've picked up over the years. They're not necessarily like, hey, I'm doing this way and everyone else is wrong. Like, if you want to use these patterns, great. I kind of see them as moving targets, right? As Docker matures as a tool and I get better as a developer and figure out new patterns, these things are definitely going to change over time. But as of right now, this is the current way that I happen to do things. And, for the sake of time, I can't really go over this file in super detail. So let's go over some patterns that you might be able to apply to your Docker files. And one of them is running your containers as the non-root user. So we can see here, we're switching over to the node user, and the official node image on the Docker Hub, it does create the node user for you by default, but it doesn't switch to it. It's on you to switch to it. And that makes sense because you might want to run things like an apt-get update, or if you're using Alpine, like you might want to use APK there to run things as a root user. And then you can switch to the node user, you can install your dependencies, and then you can run whatever command that you want to run. If it's a Webpack dev watcher or a node server, it's really up to you. There's really nothing specific to this stage here that's for Webpack. I labeled it Webpack because in the context of this application, it is managing the Webpack environment. But, when it comes more generally to installing things with a package manager, specifically in this case, we're working with Yarn, I do like to take a look here at this yarn.rc file and configure this to install these dependencies to a different location that is not going to be value mounted in development. So when it comes to Node, I'm installing things to /node modules. If I'm working with Elixir and Phoenix, I might mix install things to like /mix. It really depends on what ecosystem I'm working with. But the idea here is, I don't want all of these node modules or packages to ever be value mounted back to my dev box, because we all know the memes around node modules, right? They're pretty heavy. I don't want 100 million files value mounted back to my dev box every time I start a container in development. So I like to put them in a custom location. And, I'm actually making that directory here first, and then making sure the ownership of that directory is owned by the node user as well as the app directory here, because ultimately, that's where the worker ends up being set. But, this line's really important because it changes the ownership to the node user so that when we do a yarn install, it is not going to get like permission errors. And then, there's other parts of this file that are very, very Docker 101, right? Like we're copying in our package.json file, installing our dependencies, installing everything else. And then this line over here is super specific to PurgeCSS and Webpack. Can't really get into it for the sake of time, but just understand that this one application like hello directory, which is also in the sidebar down here, this needs to be copied in so that PurgeCSS can actually find our templates to make sure that all of our CSS gets purged correctly when we're using Tailwind. But other patterns here, we're using, taking advantage here of build arguments. So we have the node environment being set to production. And the reason why this is a build argument is down here, we're actually doing two different things depending on what the value of that node environment variable is at build time, much different than runtime. Because if this node env is set to development, then we actually don't want to build our Webpack assets because that takes like 15, 20 seconds. We're going to get our assets from over here, right? From the Webpack container. It's happily going to serve them. We don't need to like build production assets in development. So this if condition basically says, if we're in a non-development environment, then let's do that. Let's get, let's run the production build here and get our finalized assets. Otherwise, let's just basically do nothing. Let's just create a public directory that's going to correctly be owned by the node user because we're all set up to run this as the node user. But yeah, that's just one way to differentiate a Docker file for dev and prod and still be able to use the same file. Because, if I jump back over to the compose file here, this build argument is being passed in through here, through the build args. So we have one for node and one for Flask. Ultimately, these end up being environment variables in the env file, which is up here, and they default to production, but you can override them to be development in development. So that's how like that whole chain of events happens, right? They default to production as the build arguments, and then ultimately in development, this gets skipped, but in production, they get run. And then we have our final assets in that public directory, which in this stage now for the Flask application, we are going to end up being copying them in over here. So, we'll get to some other stuff up here in a second, but I just want to complete that chain here. So eventually, we're going to copy in files owned by Python, but from this build stage from Webpack into this one app public directory, this is where we're the source of this right from the other Webpack build stage into /public here. Now you might be wondering like, why not copy this into /app/public, and we'll get there in a second. But for now, that's basically how all of these compiled final like tiny little CSS and JavaScript and images get over into this build stage here for the Flask application without lugging along that entire massive node modules and the whole Webpack environment. This is really efficient because our final image now is going to be very small and it's only going to have what it needs to have. But now let's talk a little bit more about this application stage itself, the Python one. So the Python one, it actually doesn't create a Python user for you by default. So down here, I actually am creating a Python user with our home directory, just so it adheres to some best practices when it comes to Unix tools. Like some of them will expect a home directory to be set. And by the way, I should jump back to here too. Speaking of Unix best practices, it's a really good idea to set a environment variable of your user set to whatever user that you happen to be using, because some tools will potentially maybe read from that, and if it doesn't exist, it could cause some weird like edge cases or side effects. So, even though we are running this in Docker, I do like to set this environment variable. We're not really taking too big of a hit here because we are setting the node environment as an environment variable here. So we already have that one layer set up. We're just taking advantage of being able to set multiple environment variables in one layer. So now going back to down here, like before with the node example, we do switch over to the Python user, and also like before, we are making sure the ownership of the app directory is owned by the Python user. Then we do very similar things that we did before with the node environment for Webpack, where it's kind of like, copy in our requirements.txt file. This is basically package.json, but for Python. Then we do a pip install, but in this case, it's actually running a custom shell script that I wrote, which actually handles the idea of creating a lock file for Python. So you may want to check that out on your own time. Can't really go into that one here, but it's effectively a pip install, but it's running it as the Python user. There's like -- user flag. And then, down here, we also copy in all of our source code. So we take advantage of the layer caching there. And in between that, we copy in what we went over before, right, for the actual assets itself. Now, there are a couple of environment variables set here. A lot of them are specific to Flask, but if you are working with Django or another Python web framework, setting the Python path to be the current directory, which is going to be /app here, is a really good idea. You might want to set that. Then we're also taking advantage of the same pattern here for the Flask env and build arguments, because down here, we're running something slightly different versus dev and prod. For example, if it's not in development, then we run something called a Flask digest compile. Now, if you're working with Rails, Django and Phoenix, they all have this idea of being able to like pre-compile your assets, so you can have like MD5 tagged assets. And Flask doesn't do this by default, but I did write this extension that allows you to do that. That's what these lines are for here. So going down to here, we also have expose 8000. Technically don't need to set that, but it is a best practice because then when you do like a Docker PS, you can see what ports are expected to be connected to. And we have this entry point over here, which we'll get to in a second. But finally down here, we have the command. There is two ways to write this command. We are using the array syntax here. Basically, we can see each argument is in its own string here in the array. But another way to do this would be to basically just, write it all out as one big string here, not as an array. And one difference between this is when you run the array syntax, g_corn in this case is going to be PID1 in the container. But if you did the string variant of that, then bash or whatever shell that you have configured is going to be PID1. One, I guess, gotcha around this is, you can't do any shell scripting here. So like if you wanted to do like and or whatever, you'd have to do the string syntax and not the array syntax. But now let's get back to this entry point here. And before we look at this file, notice here that we are copying in our assets here from the Webpack one to /public. So now let's take a look here at this entry point file, and this will run when the container starts. And you can do whatever you want in an entry file, but in this case, what we're doing is we're actually removing all of the assets that we have in this public directory, and then we're copying in from that /public directory the new assets that were copied over from Webpack, and that's actually going to copy these into /app/public, because that's basically what the copy command does here. It will put them in public. Then we can actually volume them out on the host, and Nginx can read them nicely. Can't really go too much deeper than that for the sake of time here, but if you know a better way to do this, let me know. But this pattern has been working very nicely in practice. And going back to this compose YAML file real quick here on the bottom, notice for the web worker, we're not really dealing with assets there, so we just set the entry point to be empty so that it actually doesn't do any work. I noticed that without this line here, I was getting some copy errors because there was a race condition where the web server and the worker were both starting very, very quickly, and the copy command didn't know what the heck to do because it was trying to overwrite itself or something like that. So yeah, that's everything I have here. I know it was pretty fast, definitely glared over some stuff in the Docker file, but for the sake of time, can't really go over anything more. If you want to check out some more stuff in detail, I do have a blog where I write about this stuff in a little bit more detail. And I do have a new course coming out around deploying applications with Docker and friends. So you can always check out the courses section here to check that out. With that said, thanks a lot for watching. I really appreciate your time. If you have any comments, I'll answer them below. Thanks a lot, and enjoy DockerCon.